from this ciphertext, I want to extract plain text. I know my key length. What is the key length? It is 3. Whatever the key I'm going to have, I'm going to consider the inverse of that key. Total alphabet, it is 26. In that, I cannot able to consider even numbers and I can able to consider only odd numbers. In Affine cipher, I'm going to use 2 type of keys. One is for multiplication and one is for subtraction. Hello to all, a warm welcome to my new session on traditional symmetric key cipher. I'm Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the things what I have covered in my previous session of this unit. So there I started with type of ciphertext only attack. There I discussed what is brute force attack, statistical attack as well as pattern attack, which comes under ciphertext only attack. Then I covered known plain text attack, chosen plain text attack as well as chosen ciphertext attack. So dear student, from the examination point of view, the type of attacks are very important. But in my today's session, I'm going to deal with additive cipher, multiplicative cipher as well as affine cipher and how to perform encryption as well as decryption. So dear student, you can able to expect any one question from this topic. Now let's see what is additive cipher. So here, as the name itself indicates that we are going to use addition. Okay, so here additive cipher is also called by the name shift cipher or Caesar cipher, and it was introduced by the Julius Caesar. In that time, he used key length equal to 3, and here each character is assigned a unique integer value to the selected key value and perform modulo operation. So dear student, in the additive cipher, we are going to use only character, and the character range starts from alphabet A to Z. So what are the possible modulo value I'm going to get? That is Z equal to 26. Now, there are certain time if I want to perform additive cipher, then my A plus B value, that is my plain text value as well as my ciphertext value equal to 0 mod n. So here n is nothing but 26. And if I want to perform inverse of additive cipher, then B equal to n minus a. When I'm having negative value, in that time I'm going to perform the inverse of given number. At the sender side, P is nothing but plain text, key is nothing but K, mod 26. This is at the sender side. So after applying encryption algorithm, I'm going to get the ciphertext. And if I consider receiver side, see here at the receiver side, I'm going to have the ciphertext. From that, I'm going to subtract key and I'm going to perform mod 26 and I'm going to get the plain text. So this is the decryption algorithm. So dear student, if I consider additive cipher. At the sender side, I'm going to perform addition, and I want to perform the inverse at the receiver side. And how can I perform inverse? For that, here I'm going to use minus symbol. So dear student, what is the formula used to encrypt here? That is P plus K mod 26. And what about this one? C minus K mod 26. This is my decryption algorithm and this is my encryption algorithm. Now, dear student, this is the table I need to consider while solving any problems which comes under additive cipher. So here consider that I'm going to have the plain text equal to hello. I'm going to have the plain text hello and key length equal to I'll make it 3. I'll make it 3. Okay, fine. Now, first what I want to do, I want to draw the table. So, I'm going to draw the table for alphabet. So, I'm going to start from A to Z. So, this is my plain text and I'm going to have the value for each letter. I'm going to place the value, and while writing ciphertext, I want to write that text in the form of uppercase. So here I'm going to use capital letters to indicate ciphertext or to write ciphertext. Now see here H. Okay, so if I consider H, I want to add 3. So 1, 2, 3. H is replaced with the value K. Now, if I consider E, see here, E, I want to add 3. So 1, 2, 3. E is replaced with the value H. Okay. Now, if I consider L, after L, I want to add 3 more position. 1, 2, 3. So it is O. And if I consider second L, once again O. If I consider O, I want to add 3 more characters. So it is R. So this is my cipher text. Now, from this ciphertext, I want to extract plain text. I know my key length. What is the key length? It is 3. So, here what I want to do, I want to subtract 3 letters. So, I'm going to start from K. I want to subtract 3 letters, 1, 2, 3. So, I'm going to get the plain text. It is H. If I consider H, I want to subtract 3 letters. So, I'll get E. And if I consider O, I want to subtract 3 letters. So, I'll get L. If I consider O, I want to subtract 3 letters. So, once again, I'll get L. And if I consider R, I want to subtract 3 letters. So, I'll get O. Now, this is the general tracing. That means this is the way I'm going to convert my plain text to ciphertext. So, this is the encryption algorithm used to convert plain text to ciphertext. So, first what I will do, I'll write P is nothing but plain text. What it is? It is hello. Okay. Now, what is the key length? It is 3. Now, what I want to do, I'm having P of H equal to, what is the H value? It is 7. Okay, 7 plus 3 equal to 10 mod, what is N value? Here N is nothing but alphabet range. It is 26. So, it is 26. So, I'm going to get 10 mod 26. It is 10. So what is present at the position 10? It is K. Now, plain text of E, plain text of L, plain text of L, and plain text of 0. Now, so what is E value? E is 4. 4 plus 3, it is 7 mod 26. It is 7. Okay, 7. So, what is present at the location 7? It is H. Now, here it is L. What's the value of L? It is 11 plus 3. It is 14 mod 26. So, it is 14. And what is present at the location 14? It is O. And for next occurrence, same thing. Okay, equal to 14 mod 26. Once again, it is 14. And what is present at the location 14? It is 0. Now, I am having 0. So, 0 is 14. 14 plus 3, it is 17. 17 mod 26 equal to 17. And what is present at the location 17? It is R. So, what is the ciphertext I got here? It is Khohar. K-H-O-O-R. Okay. Now, from this ciphertext, I want to extract plain text. And what is the key here? Same key. So, what I will do? I'll write C. C is nothing but ciphertext and K. So, here C of H. Here C of 0. C of 0 and C of R. Now, what is K? Let me to consider K value 10 minus 3. See here, in additive cipher to encrypt, I am going to perform plus. That is summation. And here I am going to subtract. That means I want to find the difference. So, minus mod 26. It is 7 mod 26. Once again, it is 7. So, at the place of 7, what it is there? It is H. Now, what is H? What's the value of H? H is 7. 7 minus 3 mod 26. So, I am going to get 4. And what is present at the location 4? It is E. Now, I am going to have O. So, what is the value of O? It is 14 minus 3 mod 26. It is 11. And what is present at the location 11? It is L. Now, if I consider another occurrence of O, once again 14 minus 3 mod 26 equal to 11 and L. And if I consider R, it is 17 minus 3 equal to 14. And what is present at the location 14? It is 0. So, I am going to get the plain text hello. So, dear student, please make a note here. While writing ciphertext, use capital letter, and while writing plain text, use small letter. This is all about additive cipher, and it's also called shift cipher, and it's also called Caesar cipher. Now, I'm going to have multiplicative cipher. This is also example for substitution cipher. Even additive cipher is also example for substitution cipher. So, in multiplicative cipher, encryption algorithm specified multiplication of the plain text by the key. So, dear student, please make a note here. If I consider additive cipher, I am going to have the plain text value along with key. So, I am going to add, but here I am going to multiply at the sender side. That is, encryption algorithm. And what about decryption algorithm? It is inverse. So I want to perform division, but it is very difficult to perform division. For that, what I will do, I'm going to use the inverse of that number. So here, if I consider this is multiplication, then I'm going to consider the inverse of this multiplication number. So here, decryption algorithm specifies division for the ciphertext by key. That means at the sender side, I'm going to perform multiplication, and at the receiver side, I want to perform division. But to perform division, it is very difficult. For that, what I will do, inverse of that key. So here, whatever the key I'm going to have, I'm going to consider the inverse of that key. So here, if I consider this example, see, I'm going to have the plain text, and I'm going to apply multiplicative encryption algorithm. After that, I'm going to get the ciphertext, and I'm going to send that ciphertext to the receiver. So at the receiver side, receiver is going to accept ciphertext. Now, receiver is going to apply decryption algorithm along with the inverse key in order to get the plain text. So, dear student, to understand this concept, let's solve some example. So, here before solving this, I want to consider the multiplicative table. So, dear student, I want to draw the inverse table, and if I consider alphabet, I am going to have 26 alphabet, but I cannot able to generate inverse of each length of the alphabet. That means if I am having 26 alphabets, then I can able to generate only 13 inverse key. And here I am going to consider only odd number. That means for the even number, I cannot able to generate any inverse. So here I can able to generate inverse only for the odd numbers. So here let me to draw the table first. So I'm going to start from 1, 3, 5, 7, 9, 11, and I don't have any 13 here, 15, 17. Okay, and if I consider 1, it is 1, and for 3, it is 9. So now if I consider 5, for 5, I'm having 21, 7, 15. For 9, it is 3. So, dear student, if I consider 11, I'm having 19. For 15, I'm having 7. For 17, 23. For 19, it is 11. So, for 19, it is 11. And if I consider 21, it is 5. Now, if I consider 23 and 25, and for 23, which is inverse, it is 17, and 25, it is 25. So, this is the inverse of a given number. So, if I consider alphabet, total alphabet, it is 26. In that, I cannot able to consider even numbers, and I can able to consider only odd numbers. Even if I consider 13, this is also odd number, but I cannot able to include 13 in this table. And what is the possibility I'm going to get here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So I can able to get only 12 values, and this is my key value, and this is the inverse of the key. So this one is inverse of key. For example, if I get 5 for encryption, and to decrypt, I want to use 21. Now, dear student, example here. So, I am having hello. Here, I have taken hello. Now, what is the key length I have taken here? It is 7, and this is at the sender side, and this is encryption algorithm to indicate that I have written encryption algorithm. Now what I want to do, I want to multiply. So this is multiplicative cipher encryption. So what I want to do, I want to multiply. So 7 into 7, it is 49 mod 26. So 49 mod 26. So 26 ones are 26. Here I am going to get 23. Now which character present at this location 23? I am going to write here, that is X. And what is my next plain text character? It is E. What is the value of E? It is 4. See here, to get the position, I want to draw the table. So at the beginning, I am going to have plain text, then ciphertext, then the position. Same table I want to construct. That is A, capital letter A, and position 0. For B, capital letter B, 1. C, 2. Like that, it's going to vary. So if I consider this table, what is my E value? E is 4. So 4 into 7. Here 7 is nothing but my key. 4 into 7, how much? 28. 28 mod 26. So ones are 26 and I'm going to get 2. And what is there at the position 2? It is C. Like that, I want to perform multiplication cipher for all the character which is present in my given plain text. So here it is L. L is 11. So 11 into 7, 77. Perform modulo operation. So 26 ones are 26, 2s are 2 and 52. So I'm going to get 5, 1, and what is present at the location, that is 2, 1. What is present at the location 2, 1? I have to write the value. So I'm going to get the value or character Z. So I'm going to get the character Z. If I consider L once again, after performing modulo, once again I'm going to get the value 25, and which letter present at the value, that is Z. And if I consider O, what is the value of O? It is 14. After performing modulo operation, I am going to get the remainder 20. So what is this mod? Now tell me what's the difference between divide and percentage. So here division returns quotient. But if I want to get the answer as my remainder, then I want to use modulo. And when I use modulo, I'm going to get my result as remainder. So this is all about encryption. Now, if I consider decryption, so here once again I want to perform decryption. So I got the values like 23 to I got the values like 23 to 25, 25, 20, 25, 25 and 20. And what is my key? Here I am going to consider the inverse of a given key. So what is the inverse of given key? Here given key is 7, and what is the inverse of 7? It is 15. So key is 15. Now what I want to do? 23 into 15 and perform mod operation. Here also 23, 2 into 15, it is mod. And here also 25 into 15 modulo. Here also I am going to use 25 into 15 mod 26, 26, 26. Here also 26. And here also 25 into 15 mod 26. So dear student, if I consider the previous example, I want to get the plain text value 7, 4, 11, 11, 14. So I'm going to get 7, 4, 11, 11 and 14, and write the equivalent letter, that is HELLO. This is the way I'm going to perform multiplicative decryption. So here multiplicative cipher in the sense, once again here I'm going to have encryption algorithm as well as decryption algorithm, and I'm going to apply both the algorithm to provide data privacy. Now I'm going to have affine cipher. So dear student, please make a note here. Here I'm going to combine both cipher, that is additive cipher and multiplicative cipher. So here at the receiver side, I'm going to perform multiplication as well as addition. But at the receiver side, subtraction and inverse. That means I'm going to perform division. So combination of additive and multiplicative cipher together called affine cipher. Two keys are used in affine cipher. So here also we are going to use two keys, one for encryption and one for decryption. If addition is the last operation during encryption, then subtraction will be the first operation and operation during decryption. That means if I'm going to perform addition, then here I'm going to perform subtraction. So dear student, in affine cipher, I'm going to use two type of keys, that is one for encryption and one for decryption. So dear student, in affine cipher, I'm going to use two type of keys. One is for multiplication and one is for subtraction. See here, if I'm going to use T equal to P into K1 mod 26 to perform multiplication and to perform addition, it is T plus K2. So I'm going to perform addition operation with key 2. And if I consider decryption, see here, first I want to subtract, because if I consider encryption, first multiplication and last operation, it is addition. But if I consider decryption, first I want to perform subtraction, then I want to perform inverse. So this is the way affine cipher is going to work. So at the sender side, first perform multiplication, then addition, and at the receiver side, subtraction and inverse. Once again I'm going to multiply, but with the inverse key I'm going to perform multiplication. See here, see, to get my ciphertext, I'm going to have the plain text and I'm going to multiply that with the key 1 and I'm going to perform addition with the key 2 and I'm going to perform mod 26. Here once again at the decryption, I'm having cipher, I'm going to subtract that with key 2 and I'm going to perform inverse of key mod 26. So here where K1 inverse, multiplicative inverse and K2 inverse is the additive inverse of K2. So this is the way we can able to use affine cipher. Now let me to solve some problem here. Once again I have taken same example, that is hello, and these are the value of or position of each letter. And according to the encryption algorithm, first I want to perform multiplication and I want to add key. So here this is my K1 and this is my K2. It is 77, 7 into 7, 49, 49 into 2, whatever the value you are going to get, for that perform the modulo. So you are going to get the value 25 and it is Z. So here 4 into 7, 28 plus 7, perform modulo, you're going to get the remainder 4. So what is the letter for 4? It is E. And if I consider 11, into 7 plus 2 and perform mod 26, and whatever the remainder you are going to get, write down, and it is 1. What is present at the location 1? It is B. Now if I consider second one, same value I'm going to get. So here I'm going to get B twice. Now if I consider 14 into 7, first perform multiplication, then add 2 with that, then perform modulo operation. After that I'm going to get 22. That is remainder, I'm going to get 22. And what is present at that location? It is W. So what is my ciphertext? ZEBBW. So dear student, you have to calculate manually. That means you cannot use calculator. Instead of that, practice by yourself. First, what you want to do here? First, multiply first two value. After that, add 2 for that. Then perform modulo operation. Consider only remainder. So I want to consider only the remainder. Then substitute particular character for that value. This is all about encryption. Now see here, I'm going to have decryption. So what is present here? That is ZEBB. Now I'm having 25 minus 5 into 7 inverse. So dear student, here you want to consider the inverse of 7. In the previous slide, I explained during multiplicative inverse how to consider inverse. For 7, what's the multiplicative inverse? It is 15. So for the encryption, I used 7, and now I want to use inverse of 7, that is 15. Now for this inverse, that is 7 inverse, just place 15. So 25 minus 2, it is 23 into 15. Then mod 26. So I'm going to get the remainder 7. Here also 4 minus 2, it is 2 into 15 mod 26. I'm going to get the remainder 4. Here it is 0, 1 minus 2. In that situation, you want to consider B equal to N minus A. This is the formula comes under additive cipher. That means I want to get A plus B equal to 0 mod 26. 0 mod 26 or N. Okay. Suppose if I'm getting any negative value, in that time I want to consider this formula. So where N is nothing but the range and A is nothing but my plain text, and substitute. So dear student, here I'm going to get the N value 26 minus what is A? It is 1. Okay, 1, that is 25, and I want to multiply this with 15, and I want to take the modulo of that, and I'm going to get the remainder 1. And in place of 11, I'm having L, and for the next line also same thing, because here I'm going to get 1. So same method you need to follow and multiply that with the value 15, then mod 26. Once again I'm going to get the value 11. Now see here, I'm having 27. 27 minus 2, it is 20 into 15. So dear student, instead of writing 7 inverse, just follow the table which I have given in the multiplicative inverse. So for each plain text, I'm having inverse. That means for each key, I want to find the inverse key, and that is the standard table, and I need to follow as it is. So if I consider that table for 7, I'm going to have the value 15. So this is the inverse value. So here, instead of writing 7 inverse, directly I can able to write the value 15. And at the end, I'm going to get the plain text hello. This is the way I can able to use Affine Cipher. So what is Affine Cipher? It is a combination of additive cipher and multiplicative cipher. So dear student, in my today's session, I started with what is additive cipher, what is multiplicative cipher. Along with that, I explained Affine Cipher, and from the examination point of view, these three are very, very important. And in my next session, I'm going to deal with polyalphabetic cipher, ATTITUDE cipher, Playfair cipher, etc. So dear student, these are the topic I'm going to deal in my next session. Until then, keep watching and keep learning. Thank you.